Here's example 7 of solving trig equations. So here we have tangent of theta equals negative 7.3. And part A, we want to solve in the interval 0 to pi. So the way that's written, that just means 0 is less than or equal to theta, strictly less than pi. And then part B, find the general solutions. Okay, so we're going to approach this just like example 6. So we have tangent of theta equals some numbers, so let's draw a unit circle. Just so we can kind of see where we are and where the action's happening. So x-axis, y-axis, big ol' unit circle. Now the tangent function is negative in quadrant 2 and quadrant 4. So in other words, if tangent of theta is some negative number, then the terminal side of theta is going to be in quadrant 2 or quadrant 4. Well, quadrant 4 is outside of this interval, 0 to pi. Okay, so 0 to pi means quadrant 1 or quadrant 2. So we're only concerned with the one in quadrant 2. Okay, so that's our theta right here. Okay. All right, now how do we get that? How do we find out what theta is? Well, the first thing we have to do is take the inverse tangent. So if tangent of theta equals negative 7.3, then theta is going to be the inverse tangent of negative 7.3. But there's a problem with that. That doesn't give us the exact answer, or that doesn't exactly give us the answer quite yet. And the reason is that if we take the inverse tangent of something negative, we actually end up in the fourth quadrant. Because remember, the inverse tangent function, when you do that, you get something between negative pi over 2 and positive pi over 2. So negative pi over 2 and then positive pi over 2. So actually what happens is when we evaluate this, so it's going to give us a different theta. So actually this theta and this theta are different. So so these two thetas here that are the same. These two thetas here are the same as each other but different from these. So we're going to call this theta 1, just to keep it separate. Okay. Okay, so when we evaluate that, we actually get this angle right here. This right here is theta 1, and it equals the inverse tangent of negative 7.3. Okay? Now you might notice that I drew this angle here to form a straight line with angle theta. So angle theta and theta 1, they form this straight line here. That's not a coincidence. How do we know that happens? Well, first of all, theta, the way we drew theta to be a solution to this equation here. Theta sub 1 is also a solution to the equation just from the algebra we did. Okay, we took the inverse tangent of both sides, so theta 1 is the inverse tangent of negative 7.3. Therefore, theta 1 also solves this equation. But theta 1 is not the answer for part A because remember, theta 1 is outside of this interval. Okay. So since both of these solve the equation, then what that means is that they have to differ by a multiple of pi, okay? Or in this case specifically just 1 pi. And why is that? The reason is that the tangent function has period pi. So if you take theta and add or subtract pi to it as many times as you want, you're going to get another solution to this equation. So theta and theta 1 differ by 1 unit of pi. So actually what that means is if we take theta 1, okay, so take theta 1 and then add pi to it, what's that going to look like? Well, here's theta 1, so we're going to add pi to it, and then that's going to put us right here at our angle theta, which is the one we want. Okay. So if we have tangent of theta equals negative 7.3 like this, then what we do is we take the inverse tangent of negative 7.3, but then we have to add pi to it to get our answer we want. Okay. So theta then is the inverse tangent of negative 7.3, and then add pi. Okay. So to make a long story short, what happened is we just did the inverse tangent just like we did in example 6, but the problem is that puts us outside of this interval. So to get inside this interval, we just have to add pi to the answer we get here. And that's what we do here, is we add pi. Why is it okay to just add pi? Well, because the tangent function has period pi. So if you take this angle here and add pi to it, the tangent remains unchanged, the same thing. So that's why it's okay to do that. So now we have to figure out, okay, what is this value? So now we turn to our calculator. So we want the inverse tangent of negative 7.3 and then plus pi. So let's zoom in here. Zoom out a little bit. So make sure that we're in the radian mode. Okay, be very careful about that. Radian, RAD, rad for radian. So we want the inverse tangent of negative 7.3 and then add pi to that. So that's about 1.7069. And that's our answer for part A. So for part A, the answer is theta is approximately 1.7069. Okay. Now what about part B? Well, just like in example 6, all we do is we take this and then add k pi. So not 2k pi like we did for the earlier examples, but just k pi, because the period of the tangent function is pi. So we explained all that in the previous example. So this is just going to be theta is approximately 1.7069 plus k pi, where k is any integer. Okay. So for example, if k were positive 1, then we would go around halfway around once. K is positive 2, go halfway around twice, which means all the way around. So k is 1, k is 2, 3, 4, 5, 6, and so on and so forth. If k were a negative integer, then we'd go in the clockwise, the negative direction. So k is negative 1, negative 2, negative 3, negative 4, and so on and so forth. Okay. So that's really it. That's example 7 of solving trig equations.